Okay, good morning, ladies and gentlemen. We are here to go over section 5 of chapter 5 of your geometry textbooks, which covers the triangle inequality. This is a very short lesson, so it will only be one video. Again, we need to make sure that we are paying attention to this video before we attempt the online homework assignment. You have a limited number of chances on that assignment, so you don't want to do it if you're not sure that you understand what's going on here. All right, so in chapter 5, section 5, we're discussing a new-ish rule, one that kind of makes sense, called the triangle inequality. This is not a theorem or postulate, it is a property, so it does not have theorem or postulate after it. In a triangle, in order for something to be a triangle, the sum of any two side lengths must be greater than the length of the third side. So over there in triangle ABC, the following three things are always true. AB plus BC has to be greater than AC. AB plus AC has to be greater than BC. And BC plus AC has to be greater than AB. If even one of these inequalities is not true, then it is not a triangle. So all three of these things must be true in order for three side lengths to form a triangle. The sum of any two sides must be bigger than the third side. Okay, so first problem type that we generally see is them giving you three potential side lengths and asking you to decide whether or not those given lengths could form a triangle. Now, the directions also say to explain why not if it's not. So the big thing here is that we need to show our work. Okay? So we have essentially three side lengths. We'll call them A, B, and C. And what we have to do is go in and check to make sure that all three inequalities are true. Okay, that's what that question mark means. We're asking, is A plus B greater than C? Okay, so we go in here and we say, okay, 8 plus 15, is that greater than 17? And this should be relatively simple. I mean, 15 plus 8, that's 23. Is 23 greater than 17? Yes, yes it is. Okay, we move on. So if 8 plus 17, is that greater than 15? Well, 8 plus 17, that'd be 25. Yeah, that's absolutely bigger than 15. So that's also true. Same thing for B and C. 15 plus 17, is that greater than 8? Well, yeah, 32 is definitely bigger than 8. So our answer here would be yes, because we have fulfilled the triangle inequality. Okay? All right, just pause the video and try the second one on your own before you listen to the solution, see how you did. So we have three side lengths again, A, B, and C. Again, we need to go in and we need to check to make sure that all three possible combinations of sides are greater than the third side. We're checking the triangle inequality. So 6 plus 8 has to be greater than 14. 6 plus 14 has to be greater than 8, and 8 plus 14 has to be greater than 6. So we go in and we check, and we ask ourselves, is 14 greater than 14? No, it is not. Is 20 greater than 8? Yes, it is. Is 8 plus 22 greater than 6? Yes, it is. The answer, however, is no, because of this false statement. 6 plus 8 is not greater than 14 would be our explanation. Okay? 6 plus 8 is equal to 14. The rule says it has to be greater. Equal is not good enough. Okay. The other problem type that we could see involves coming up with a range of values for the third side of a triangle. So what they'll do is they'll give you two side lengths and they'll say what values could represent the length of the third side. Okay? So we have two values. We'll call these A and B. And we don't know the third value. The third value is going to be x. Okay? What we do is we set up all three of our inequalities. So 4 plus 8 has to be greater than x. 4 plus x has to be greater than 8. And 8 plus x has to be greater than 4. And we solve all three of those inequalities. So on the first one, there's not really much to solve. All we can do is combine like terms. 4 plus 8 is 12, which means that 12 is greater than x, which when we write these, we tend to put the variable on the left, so we would flip that whole thing around and say x has to be less than 12. On the second one, we would subtract 4 from each side, which would give us x is greater than 4, because the subtraction property applies to inequalities as well. And the same thing for the last one, we would subtract 8 from each side to get x by itself, which would give us x is greater than negative 4. Now, we don't need all three of these answers. We only need two of them, but there's no telling which two we're going to end up needing without thinking. Okay? It's not like I could just say, oh, you never need the third one. You have to look at what you have. What we've got here is x is less than 12, x is greater than 4, and x is greater than negative 4. Well, every value of x that's greater than 4 is already greater than negative 4. So by keeping this answer and ignoring this one, we're still covered because everything here fits this description as well. So essentially what we're looking at is we are looking at a range of values that says x has to be greater than 4 and it has to be less than 12. So when we write that, we write it as a range of values 4 to 12 would be our final answer. And in theory, since we were given units, we should probably include units. 4 feet and 12 feet. Any value between 4 and 12 feet would work. Okay, pause the video, try the next one. Yes, it has decimals. No, that doesn't matter. Try it anyway. And then resume the video and see how you did. So here's our final example. Again, we're going to insert an x for our third side length. So all three of our inequalities must be true. 3.8 plus 9.2 has to be greater than x. Why do I keep doing that? 3.8 plus x has to be greater than 9.2. And 9.2 plus x has to be greater than 3.8. On the first one, again, all we're going to do is combine like terms. 3.8 plus 9.2 is 13, is greater than x, which means that x has to be less than 13. Subtract 3.8 from each side. Gives us that x is greater than 5.4. And finally, subtract 9.2 from each side, which would give us x is greater than negative 5.4. Again, we don't need this one, because if x is greater than 5.4, it's already greater than negative 5.4. So we take these two and we combine them into a range of values for the third side, which would be all values of x that are greater than 5.4 inches and less than 13 inches would be our final answer. You have an online assignment on Google Classroom to complete. It is due on Tuesday at 3:30 p.m. Thank you very much for your time and attention.